All right, so 4-3 still continued. This is part E, okay, which is now the third conic, which is called a hyperbola. And a hyperbola looks like this. So it technically has two, not technically, it does have two what are called branches, which look like parabolas pointing in opposite directions. So by definition, it's the set of all points in a plane, the difference of whose distance from two distinct points, the foci is a positive constant. The difference in our equations now is there's a minus between them. So it looks almost exactly like an ellipsis equation, except instead of a plus being between them, it's a minus. Those two arcs, like I just said, like they look like parabolas. They actually would have arrows on the ends of them. They are called branches, and they can either be vertical like these are, or they can turn to be horizontal. The curves are called branches. So this is your branch and this is your branch. Okay, there are two of them. The center will be halfway between those. So your center is still how you kind of like basically start your graph. There are two foci this time. Like your parabola, the foci occur inside the curve. And then the axes have different names. So our major axis is now called the transverse axis. You're going to see on the next slide, you'll get a little bit more. And the distance for A is still the same. A is still distance from center to vertex. C is still the distance from center to foci. And B, which you'll see in a second, is still the distance from the center to the co-vertices. It's just very different how we use that. So all of that is the same. It's just how we show this on a graph is a little bit different. So the center's still in the middle. You would still go up and down or right and left the A distance to get your vertex. You would still go in that same direction, C, to get your focus, except that your focus has to be further out than your vertex. So in an ellipse, A has to be bigger than C. In a hyperbola, A has to be smaller than C. And then D again shows, I'll show you on the next graph, but D would be your to your co-vertices, which tells you how wide or narrow to make your parabolas. Okay, and the biggest two differences, well, three. One, there's a minus between the x squared and the y squared on your equation. That's the major difference in your equation. Second, A is always first this time, not necessarily bigger. So where A is the bigger one on an ellipse, A is always first on a hyperbola. And the other big difference is C squared equals A squared plus B squared. So in an ellipse, it's a minus between there. All right, now look at your equations. If x squared comes first, so if it's x squared minus y squared, then it's horizontal. My branches point to the right and to the left. A is still at that vertex. C is inside the curve of the branch. And here's B. So B would go in the opposite direction. There are two ways to graph these. One is find the equations of the asymptotes, which are those dotted lines, and then graph those equations. And that tells you how wide to make your branches. In my opinion, the easier way to do it is to make what you see in the background, which is that box. Will you open the door for Maria? Oh, there she goes. So if I were to graph, I would start at my center, wherever the center is. So right now it's at 0, 0. Good morning. You could have come too. Thank you. If it's horizontal, you're going to go to the right A and to the left A. So this distance would be A. You're going to go up B and down B. That's the distance to the vertices, the co-vertices. And then you make yourself a little box that passes through those points. It can be square, but usually it's rectangular. I find the corners of my boxes and I draw diagonal lines through them. And then I draw the branches off the vertices as wide as those asymptotes will let me. Yep. Right under it. So you don't want it, it's an asymptote. So technically you don't want it to touch the line. I mean, you don't have to be perfect, but you don't want it to touch the line. You want it to be as close to that line as you can get. So again, as we work through, you'll see we do most of it the same as we did with the ellipse. We're going to find the A, we're going to find the B, we're going to find the C, we're going to plot the center, then we're going to count out the A to get the vertices, we're going to count out the B to get the co-vertices. The only difference is then come these asymptotes. Good morning, thank you. Then come these asymptotes, and then go the branches. The foci, if it asks you to graph, will always fall inside the curves, just like your parabolas. So they'll be inside those scoops. That would be your horizontal one, okay? And then your vertical one, you just reverse it. I would still find A, B, and C. I would find my center. This time I would go up and down the A to get the vertices. I would go right and left the B to get the co-vertices. I would draw my little rectangle. Again, it could be a square because A and B can actually be the same. I would find those corners and draw the asymptotes through them. And then the parabolas come off the vertices as wide as I can make them without touching the asymptotes. And again, focus would fall inside. That would be the C distance away. It would fall inside the parabola. The other thing on this slide that hasn't happened yet is it just named our minor axis is now transverse. So major is major is transverse. Minor is called conjugate. And we'll use those more with like finding the equation. It's still the same 2A and 2B. But you'll see when on Monday, when you start to find the equation, it'll say like the transverse axis is 12 instead of giving you the major axis. You just got to know transverse and major are the same, and then minor and conjugate are the same. Again, A is always first in hyperbolas. C squared equals A squared plus B squared, and there's a minus between the two fractions. Those are the three biggest differences. All right, so let's start. Oh, I'm sorry, and then the asymptotes. It will sometimes ask you to find the asymptotes, most of the time actually. So you'll give these equations, okay? If you choose to graph with them, you can, but you don't have to. You can use the box, and I actually think the box is easier. If it's asking you for the equations of the asymptotes and it's a horizontal hyperbola, then it's y with a center at 0, 0. Then it's y equals plus and minus b over a x, which means there are two asymptotes. We just drew them. If it's a vertical hyperbola, then it's y equals plus and minus a over b, x. So there are two equations there. In both of these, the center's at 0, 0, so your y-intercept would be at 0, 0. So the change is the b over a and the a over b. All right, now we go. It says find the center, the vertices, the foci, the asymptotes, and graph. Step 1 here is the same as step 1 on ellipses, which is what? Make it equal to 1. So the very first thing I have to do is divide everything by 16. And I'd get x squared over 4 minus y squared over 16 equals 1. Note there's a minus in between them because eventually these are all going to get looped in together, and the way you figure out if it's an ellipse or a hyperbola is that, the minus in between. All right, so now I go center. There's nothing adding or subtracting from the x, so or the y, so my center is 0, 0. What letter comes first? The a. So a squared is 4, which means a is 2. And what variable is over that a? The x, which means this is horizontal. The b squared is 16, making b 4. And it asks for the foci, so c squared equals a squared plus b squared this time. Yep.
How do you find out that it is horizontal?
Whatever comes first, whatever letter is there first. So if it's x, x is the positive one and y is the negative one. Then it's horizontal. If y comes first, so the x has the minus on it, now it's vertical. So it depends on what comes first this time. If x is first, it's horizontal. If y is first, it's vertical. Yep. You're welcome. All right, so then c squared equals a squared plus b squared. C squared would equal 4 plus 16. C squared would equal 20. And c would equal the square root of 20. If we want to graph that, we're going to approximate it to be, it's in between 16 and 25, so like a 4.5 when we graph. But when we find the actual coordinate points, we're going to keep it exact. So 20 would be 4 and 5, or 2 root 5. Then we go to our graph. So my center's at 0, 0. It's horizontal, which means I go right and left the A. So I go right 2 and I go left 2, and those are my vertices. So negative 2, 0, and 2, 0. I go up and down the B, and the B is 4. Up and down B, and those are my co-vertices. 0, 4, and 0, negative 4. And then I draw my little box. I mark the corners of my box. And I draw the asymptotes through those corners. And then I draw my parabola, or my branches, as wide as I can get them in the horizontal. So I'm going to come from my vertex up here, down here, and do the same thing on the other side. Up here, down here. The foci would fall inside those branches, so I would add and subtract 4.5 in both directions to graph it. That's my focus and my focus. But to give those coordinate points, I keep it exact. So I would take my x, which is 0, add and subtract 2 root 5. If it wants them separate, obviously you need to separate it out. Negative 2 root 5, 0, and positive 2 root 5, 0. Questions so far? We still have one more thing to get, and that is the asymptotes. So the asymptotes are y equals plus and minus. Because it's horizontal, it's b over a x. So my asymptotes are y equals plus and minus. The b was 4. The a is 2, which simplifies to plus and minus 2x. So those are really just two equations, two y equals mx plus b equations. Y equals negative 2x and y equals positive 2x, which should overlap with the lines I drew from the box. Positive 2x would start at the 0, go up 2 and over 1, up 2 and over 1, and I would get that same line. Negative 2x would start at 0, 0, go down 2 and to the right 1 again, and I'd get that same line. So I recommend the box because I think it's easier, especially if we shift this off of center, but you can also use the equations of the line. Yeah. So the equation for asymptotes when the center's at 0, 0 is either y equals plus and minus b over a, or if it's vertical, a over b, x. So I literally just figure out what b is. In this case, it's 4, a was 2, and I put them over each other, simplified. And then when I graph it, if you wanted to graph it using those, you're in y equals mx plus b form. So you got to figure out what b is. In this case, it was 0, and then go your slope from there. But I would recommend the box. I think the box is easier, especially we're going to move this around, and then it's harder to find those lines. It's going to ask for those asymptotes, so you have to learn how to get that equation, but you don't have to graph it using that. You're welcome. We're going to do it again. Yep. One is divide everything by 100. It's got to be equal to 1. So y squared over 4 minus x squared over 25 equals 1. So tell me what you know already. It's vertical because the y comes first this time. And vertical for me, as soon as I see vertical, I put a over b because that helps me with my asymptote for later. So vertical asymptotes a over b, horizontals b over a. My center's where? 0, 0. My a squared is always first. What's first? 4, which makes a 2. My b squared is 25, which makes b 5. And c squared would equal a squared plus b squared, which is the square root of 29. Now that doesn't simplify, but I'm going to approximate when I graph it. It's in between 25 and 36, so we could make it like a 5.5. It's probably a little bit closer to 5, but it doesn't matter. It's not that specific. I can find my asymptotes already too. Asymptotes. Y equals plus and minus a over bx. So y equals plus and minus. The a is 2. The b is 5. X. Then I go to my graph and I plot all the things I know. Center at 0, 0. It's vertical, so I'm going to go up and down the A, which is 2. And those are my vertices. I'm going to go right and left the B, which was 5. And those are your co-vertices. I'm going to draw the box. Find the corners and draw the asymptotes through those corners. And then it's vertical, so my branch is going off the vertex, up and down. My foci is C distance away from the center, which we approximated to be about 5.5. But when we write it, we keep it exact. So the foci is plus and minus square root 29, 0. Wait for it. There it is. And then we already found our asymptotes, but if we overlap them on the graph, if I find my b at 0 and I do my slope at 2/5, I can go up 2, to the right 5, down 2, and to the left 5, and to the right 5, and I should end up with those same lines. Questions so far? Checking the asymptotes. The first one would be positive 2/5 x, right? So I'd start at 0, I'd go up 2 and to the right 5, and I'd be on that same corner. But you can use the box. You're welcome. And then I would have done the same thing with the negative 2/5. All right, so if we shift the center off of 0, the only thing that changes in my equation is there will be something added or subtracted from, in the parentheses, from the x and the y. So if there's something in the numerator with the x or the y, just like with the ellipse, then it shifts my center. And then we use that center to count everything out. So if it's vertical from the center, we go up and down the A and right and left the B, draw the box, draw the asymptotes, draw the curves. If it's horizontal, we go right and left the A, up and down the B, draw the box, draw the asymptotes, draw the curves. Everything else is the same, okay, except your asymptotes. So the equation of your asymptotes now include K and H. So if it is horizontal, it's still B over A, but it's K plus and minus B over A times x minus h. And if it's vertical, it's y equals k plus and minus a over b times x minus h. So the two major differences, if it's not at 0, 0 anymore, is the numerators will have parentheses with something in them, and these equations for the asymptotes change. All right, so look at 3. What can you spot immediately? The center is no longer at 0, 0. It's the opposite of what follows x, so negative 3, and the opposite of what follows y, so negative 2. What else do you know without having to do any arithmetic?
It's vertical.
It's vertical because the y comes first. Good. It's vertical, which I'm going to put over here. That means a over b because that helps me with my asymptote for later. The a squared is 9, which makes a 3. The b squared is 4, which makes b 2. C squared would equal a squared plus b squared. 9 plus 4, which is 13. So C is the square root of 13. Can't be simplified. Obviously have to be approximated when I graph it. It's in between 9 and 16, which means this is like a 3.5. But we'll keep it exact when we find our coordinate points. Our asymptotes, y equals k plus and minus a over b x minus h is my equation for vertical. Y would equal, the k is negative 2 plus and minus A is 3. That is the ugliest. 3 over B is 2. X minus H is a negative 3. So minus the negative makes this positive 3. And that's why I would say it's easier to use the box. So if I want to graph this, that's in a really weird format. I think the box is easier, okay? You need to know how to give it, but you'd have to distribute the 3 halves and then combine like terms to put it into y equals mx plus b form, which I think is more complicated than it needs to be. Center's negative 3, negative 2. Negative 3, negative 2. Then I go, because it's vertical, up and down the A. 1, 2, 3. Down 1, 2, 3. And those are my vertices. Negative 3, 1. Negative 3, negative 5. I go right and left the B, which is 2. Those are my co-vertices. Negative 5, negative 2. Negative 1, negative 2. And I draw the box. Find the corners. Draw the asymptotes through those corners. And it's vertical, so the branches point up and down. And the foci fall inside those branches. I'd go from my center up. We approximated 3.5. 1, 2, 3.5. 1, 2, 3.5. So that's what it would look like on the graph. But when you're giving these coordinate points, they have to be exact. We adjusted the y coordinate because it's vertical. So if I come to my center, I'm going to take the y coordinate and add and subtract the c, which is square root 13. So my foci are at negative 3, negative 2, plus and minus square root 13. Or you could write it out separate. Negative 3, negative 2 minus root 13. Negative 3, negative 2 plus square root 13. So that's the trickiest part when it's not as center at 0, 0, obviously. You got to make sure you're changing the right coordinate. So because it's vertical, we added and subtracted the c to the k. If it was horizontal, we'd add and subtract the c from the x or the h. Questions on that one? Okay, last one. Yeah, question? 4. So tell me what you know right away.
It's
Horizontal because the x comes first. And if it's horizontal, it's a b over a for my asymptote. You can even write out your whole equation for your asymptote if you want. Y equals k plus and minus b over a x minus h. What else do you know from your equation? The center is what opposite of what follows x. Good. 3 and opposite of what follows y? 2. Good. What's missing from under the x? What should be there if there was a number visible? It would be a 1. Okay, so it's not that there's no a squared, right? That it's just that a squared is 1. So a squared is 1, making a 1. B squared is 9, making b 3. C squared equals a squared plus b squared. So c squared equals 10. And c equals the square root of 10. Can't be simplified. We have to approximate it for when we graph it. It's just a smidge bigger than root 9. So this would be like a 3.1 or 3.2. Again, you're just approximating to graph. My asymptotes our y equals the k, so the y coordinate of your center, which is 2, plus and minus b, which is 3, over a, which is 1, times x minus h, which is 3. And then obviously you don't need the over 1. You could just leave it as 3. Yep.
What's the equation without the numbers placed?
That's what this is. Oh, wait for it. Right underneath where it says horizontal. Y equals k. For horizontal, it's b over a. For vertical, it would be a over b. But everything else is the same.
How do you know the K and H?
It's the center. K, H is your x coordinate of your center. K is your y coordinate of your center. You're welcome. Okay, now I bring back in the graph. I'm going to start by plotting my center at 3, 2. This is horizontal, so we're going right and left the A, which is 1. Those vertices are 2, 2, and 2, and 4, 2. I go up and down the B, 1, 2, 3, 1, 2, 3. Those are your co-vertices. 3, 5, and 3, -1. You're going to draw the box. You're going to find the corners. And then draw your asymptotes. It's horizontal, so the branches are coming from the right and the left off those vertices. And the foci would be 3.1 away from the center. 1, 2, 3.1, 1, 2, 3.1. Which means we're adjusting the x coordinate of my center by adding and subtracting the square root of 10. The y stays the same. So it would be 3 minus root 10, 2, and 3 plus root 10, 2. Questions?